Next up, we're going to talk about a third rule for selecting the g that go into our undetermined coefficient formulation that I've called repeats. So again, go back to that place where we talked about how to make g in your notes, and we're going to be filling in that part C. And so our rule is going to be that if any of the functions g sub I of x we picked from doing part A or part B, if those are part of the fundamental solution set, those y1 through yn, or alternatively, if they're things that would be the general solution to the homogeneous problem, then we can't use them in y sub p. And instead what we're going to do is we're going to multiply by x until you get a new function. So, for example, if we found g1 equal to e to 4x, but from our fundamental solution set y1 was e to 4x and y2 was e to 2x, this is a problem for me. I can't use g1 equal to e to 4x because it's a copy of something that already exists in my solution set. So I multiply by x. Now I have x e to 4x. That's new, it's different from everything I've seen before, so I'm fine. If I multiplied by x and I still didn't have a new function, I would keep multiplying by x until I did. And we're going to do an example that shows us how this comes into a problem. So if you're still writing those steps, go ahead and hit pause. I have to flip all the way back to a new page so that we can write an example. So here we go. And the example we're going to do is we're trying to solve y double prime minus 5y prime plus 4y equal to 8 e to x. We're going to note that y double prime minus 5y prime plus 4y equals 0 has solutions y1 equal to e to x and y2 equal to e to 4x. Again, if that wasn't given to you, you would have to find it, and it actually ends up being more important than just for writing that general solution. In our previous examples, we only used this information at the last step, but now we're going to know that actually as soon as we write down our particular solution guess, we need those functions to check. So in this case, g on the right side is 8 e to x. So that's not a very good A. A would tell me that I want to include things that look like e to x, and B would tell me that derivatives actually just stay e to x, so I don't have to introduce anything from B in this case. But now this new rule that we have to think about is that e to x is already in our solution set. It's part of y1. y1 is e to x. So I need to multiply by x to get a new function. That means my y sub p is going to be a, and instead of being e to x, it's going to be a times x e to x. So x e to x is different from e to x, and it's different from e to 4x, so I'm fine. This is a new function. It came from e to x. It addresses derivatives, and it does not copy y1, so I can proceed with this. to take my derivatives, I need to use a product rule. So y sub p prime is going to be a times derivative x is 1 times e to x stays the same, plus x times derivative e to x, which is just e to x. Or that's a times 1 plus x e to x if I pull out that common term e to x. And then yp double prime is a times derivative of all this stuff. So derivative of 1 plus x is still 1 times e to x. And then I keep 1 plus x the same, and I take derivative of e to x, which is just e to x. And if I want to simplify this a little bit, I've got a times 2 plus x e to x. So next, we got to plug it into the ODE. I'm going to go ahead and move to the next page. That way, like when I start setting up my equations, I don't have to bump pages like we did last time. So hit pause if you're still writing. But I'm going to get that on the right side was 8e to x, and that's going to stay the same for a while, so I put it over here. And then I want that equal to yp double prime minus 5yp prime plus 4y sub p. That's going to be a times 2 plus x e to x. I just calculated yp double prime. Minus 5 times y sub p, which was a times 1 plus x e to x. Plus 4 times y sub p, which we just assumed was ax e to x. To make everything look simpler, I'm going to note that there's e to x just in every single term of my equation. So I'm going to go ahead and cancel all those out. And I'm going to be left with that 8 is equal to a times 2 plus x minus 5a times 1 plus x plus 4ax. And distributing through, that gives me 2a plus 2x from this first term. When I distribute this one, I got to make sure that minus 5 hits every term. So I've got minus 5a minus 5ax, and then finally plus 4ax. That's going to simplify to, let's see, 2a minus 5a, and then I see x in every other term. Sorry, I just noticed this looks weird to me, and it's because I just copied it down or distributed it wrong. I don't know what I did, but that was definitely a times 2 plus a times x. So this term right here, make sure you've got an a instead of a 2 if you didn't catch that while I was writing it. And then I've got x times a and x times 4a. So my constants and my x's, I'm just grouping them together because I know I'm going to want to simplify them eventually. And then on the left side, I know that I've got 8 is a constant, and I don't see anything that looks like x. Similar to when I take derivatives and introduce terms that don't appear on the left, when I take care of repeats, I'll introduce terms that don't look like what's on the left. But that just means their related coefficient is 0 on the left side. And then on the right, this is going to go ahead and simplify to minus 3a plus x times 5a. Something is wrong. I found it. And this is where it's helpful that I underline everything as I'm grouping terms, because if you look over here, there's a term I never underlined. I don't know why. I just decided to skip it, I guess. But now I see exactly what I missed. And I can really easily say, oh, I was supposed to have minus 5a in the squiggly x terms right there. And the reason I knew something was going wrong was because I only have one unknown a, so my equation should simplify to one condition for a. I was seeing too many. I knew something was wrong. You might get to the end of the problem and find something's wrong, but no matter what, we just gotta be careful, go back. It helps to write out all our steps so we can catch it when it happens. If you remember to write down the minus 5a, then we can see that a plus 4a minus 5a actually becomes 5a minus 5a, which is just 0. And so those two equations or groups of coefficients are already sort of true. We just have 0 equals 0. When we're trying to write down our systems of equations, we set the 1's equal and we get 8 equals minus 3a. And if we set the x's equal, we just get 0 equals 0, which is always true, thankfully. That means we can just go ahead and solve for a, which is minus 8 over 3. That means our y sub p, which we assumed was ax e to x, is just going to be minus 8 over 3x e to x. So we're again going to do that general solution of c1y1 plus c2y2 plus y sub p, or c1 e to x plus c2 y2 we didn't use, so I've already forgotten what it was. It was e to 4x plus y sub p, the thing we just found, is minus 8 over 3x e to x. And that is how we do one of these repeat problems. In the last video, we're just going to do a kind of complicated example that combines all this stuff together for us.